So hello everyone. So today we are going to look on a project, basically how to do a machine learning project, especially for the placements or your career. So this is a project where we are gonna predict heart disease with using some sort of data. So you can see that we are going to predict the heart. So here is a nice image. So I'm using Google Colab for this environment. So you can use Jupyter Notebook on Anaconda or anything. Whatever you are comfortable with, just go for it. So now let's have a look at how these things are going. So there is a problem statements. So basically what we want to do is to design a predictive model with the use of machine learning algorithm. So those who have knowledge of machine learning, so you can easily relate or connect with that. The purpose of the machine learning is to design some sort of predictive models, or maybe some sort of predictions, maybe in terms of class, or maybe in terms of associate measuring the associations or clusters or anything. So in this case we are going to predict whether there is a heart disease or not. So as you can see that this is a classification problem. So so in the previous video we discussed about the supervised and unsupervised learning. So always keep in mind that classification problem is comes under unsupervised. A classification problem comes under supervised learning. In unsupervised learning, what types of problems are come? Just like associations or cluster, these are the things which comes under unsupervised learning. But in supervised learning, these types of classification problems can be sorted out. So, what are the basic things we have done? So, basically, the first step in any analysis is to load the data set. So for loading the data set, so what type of data we have taken, this is very much important. So now there you can see that the data information is given. So this data set is 1988 and the consist of our database. So you can see that this is the informations of the data. So basically the data is coded as binary variables, binary coded just like 0 and 1. So you can see that if the 0 is present in the target, then that means no disease, and if 1 is present, then there is disease. So next there is some sort of attribute informations, that what are the variables we have taken here. So there is age, sex, and chest pain, resting blood pressure, and serum cholesterol, and fasting blood sugar, and resting electrocardiographic results, and etc. These are all the things which you can have a look. So now we will look on how to sort out this problem, or how to build a predictive model. So now this is the code which you can run to connect your collab with Google Drive. So basically the code need to be interpreted. So basically this is a mounted code. So what is mounting? So basically I need to connect my Google Drive with Collab. So there is two way that you can do this data loading process. So the first is just go there, files, and you can just upload your CSV files in the file section. Here you can see that there is options of upload, and after uploading, you can do the all the stuffs, and then you can go for the whole process. But basically the problem is that when you upload some sort of file, and when the coding is being done and you leave the environment, then when you come back you need to again upload that file. So to get rid of from this problem, the simple possible way is to connect the Google Drive with Colab, so that your file will always be stored in Drive, and the Colab will always mount it from the Drive. So there is no chance that when you leave the Colab, you lost your file and you have to upload it again. So The next part is basically we have to define the file path. So here you can see that I have these types of folder just like dataset. I have a folder in the drive which is named as dataset. So it's depend on you, whatever you think is best name, so you just go for the name. And my all of the data just like big basket, big bazaar, all the data whichever I have collected from the various sources from the web, all are stored in the dataset folder. So now let's move on. So basically we the first task is to import the pandas. So why import pandas? Because we are going to work on a data frame. So for this reason we need to import pandas. So we need to import pandas. You can see this is the command for import pandas as pd. You can write here any other whatever you want to write. Maybe you can write here ex or es, anything, but the general term which is used is pd. So basically we imported the pandas as pd, and after that whatever we have done, that we define the data frame. So basically df is the name of the data frame, and df is what? Df is all about reading the csv file. So you can see that the file path, and we have the csv file named heartattack.csv. Basically it's a heart disease, so I just randomly named it as heart attack, so you can just sort it out. So the file is here in the list. So you can see that there is a file, and the name of the file will be put it there, and your data frame, whatever you have put in the name of the data frame, will be mounted from the drive. And you can see that after that you can see the data information, but by just clicking on df.info, and here is the informations of the data. So you can see that there is the information. So there is all the values, what are the data types. So basically these values are in integer, and this value old peak is in float. So now the next step which is comes that the data types. So we can see that there is one old peak variable is there which is in float, and else every variable is in integer. The next thing is that is there any null value. So whenever you just go through the basic sort of EDA or something, basically I don't just did EDA so much there. We will do it later. I will explain all the things. But the basic thing is to check some sort of basic descriptions of the data. So is there any null value? So you can clearly see that there is zero null value. If there will be some presence of null value, then you have to sort it out with some sort of domain knowledge, or maybe mean median, whatever you think is possible. So these are the things, and basically this is nothing but just cloning the data frame. Now the point is why we should clone the data frame. Because if you are working with the raw data frame, then in different steps you are doing different types of tasks with the data frame. So when there will be some sort of mistake, it's difficult to get the real data or original data back. So in that sense I always try to clone the data frame. Because if I work with df2 and I have done some sort of mistake, then I will simply call the df easily, because the df is previously mentioned, and df2 is nothing but the clone of data frame. So next, we will move to the EDA part. So EDA is exploratory data analysis. So in this part, we require some sort of packages just like matplot and matplotlib pyplot and seaborn and plotly. So now look, seaborn is enough to describe all the charts and plots, and plotly is also a very advanced package to in terms of visualizations. So basically in terms of EDA, we will just install or require these types of package. Matplotlib is very basic things. So it's basically not basic, but it's beginners friendly. And Seaborn is also quite good, and Plotly some required some sort of advanced things, and but the visualization which comes from Plotly is really great. So when I will do the Plotly visualizations, and then you can see that how beautifully the plots or charts comes from the Plotly. Next. Next is this is just nothing but a code. If I you can write this if you want the dark grid style. So there is some different grid style. So you can see that these are the columns which are there. So age, sex, CP stand for chest pain, and all of these you can see. So the next is overview of the data. So basically we just put here head, and if you, and as we put their head, the top five data points are there. So you can see the index. Now there is the four, but we in head function the top five data are visible. So why this four? Because you can see that the indexing is started at zero. So if you count at 0, 1, 2, 3, 4, so total five data points are visible. So this is all the data frame. So now we can see that the data type again and nothing but now we will look at describe. So some basic statistics. So you can see that there is some basic statistics. So these statistics will help you to understand the data or the type of data very well. So df2.describe. So this is the syntax for describing the data frame. So when you describing a data frame, you can see that these are the basic statistics, count and mean. You can see, so this is the count. So as we see that there is no null value, all the counts are same, and the mean is that, and standard deviations you can see, and the minimum, maximum, the range. You can see that the minimum age is there is 29 and the maximum is 77, and these are the quartiles 25%, 50%, and 75%. So this is the basic overview. So now is we are looking on the shape that you can see that there are 1025 data points with 14 different variables. So next part is visualizations and distributions. So now look at visualizations. So now we will use a, now look, SNS is nothing but seaborn. So we bring seaborn to count some sort of data. So we basically count our target. So you can see that this data is quite balanced. So what happened if this data is unbalanced? Then we require some different types of data processing or some different types of data evaluation. So is required. So now you can see that in this problem the data is balanced, so we don't require some special or specific levels of evaluations. So SNS, this is the count plot. So basically we bring count plot to count that how many there are heart disease, how many heart disease are present, and how many heart disease or how many cases there are no heart disease. So you can see that if there is 0 and the 1, so you can see that in the first case we defined as 0 and 1. So basically 0 means there is a presence of heart disease, and 1 means there is presence of no heart disease. So in terms of that, you can see that almost the data set is balanced. Now we will look on subplot. So basically we will look on subplot. So in subplot we have the ability to plot two plots in the same place. So in that sense we will bring subplot. So in the seaborn we use histogram of age. So you can see that the distributions of the ages are there, and next is, and you can see that the hue means the target is there. So you can see that the maximum ages are between 50 to 60, and this is the hue which tells us that is there is a heart disease or there is no heart disease. So you can see as the age increases, the heart disease comes to the points. So you can see that the colors are changed. So in that sense you can quite get some sort of knowledge about the data from just doing some sort of EDA or just looking at the data. And we will look at some sort of box plot, that if you see that there are some outliers or not. So we will look that our data is quite okay, there is not such serious or major issues. Next is sex, the distributions of genders. So you can see that the distributions of genders are there, and you can also see that that this is the count. So you can see that the target is there and the count is also there. So the gender is also coded as 0 to 1. So all of these are explained, so you can just simply put this code. So now look, I will put the GitHub link in the description below so that you can get the code. But for now, just understand the explanations. So in the count plot, whenever we do some C1 plot, so basically whatever we do, we bring subplot here also, and this is the figure size. Figure size defines that what will be the size of our figure. If the figure size is large and if we put some large figure size, then the one figure will take the entire screen. So in that sense, you need to do some sort of optimal figure, define some sort of optimal figure size. And the next is there is subplot. So you can see that there is one or two. So basically we plot the subplots, and in terms of subplots we just two plots we are plotting. The one is the two count plots are plotting. One is for sex, and we just change the hue as target, and the next is just basic simple count. So you can see that these are the things which you can understand, and this is nothing but the palette. So what is palette? Just because of the colors, you can see that there are some nice colors. If you want to change the palette, then just look at how the seaborn palettes are work, and just change the name here. I put their verdis. You can change there anything whatever is available on the seaborn, and according to your taste and preference, the colors of the plots will be changed. And then and this is nothing but the axis. So why this is, we put there ax and axis? So just nothing but just for the plots. So this plot is first and this plot is second. Next is chest pain. So why chest pain is required? So basically we try to find out every variables, so and look at the distributions and how the variables are being distributed. So in chestpen, we use the same function and we try to see that what is the case there. We can see that there is a count and there is a chest pain. So we can see that the chest pain is very high in some particular cases. So in that sense, wherever there is the chest pain is high, there is a chance of getting the heart disease. Okay, we understand that. Next is we plot some sort of bio plots and some sort of histogram, and again we try to check the outliers. So why do we require box plot? We require box plot to understand the presence of outliers. So here you can see that some sort of outlier is there. The points are there. These are nothing but just the outliers. So if the outliers are too much, then we need to correct immediately. We need to fix it with the help of domain knowledge. And there is also some sort of rules, just like if the outliers is less than 5%, then it's quite okay. But when the outliers exist 5%, then we require to fix it with help of domain knowledge or some sort of things, because we are the, if the outliers is more than 5% and we are trying to remove it just by eliminating or deleting or putting the mean median, then we are going wrong because we are ignoring the real fact. So in that sense, we need to require to put the outliers if it is less than 5%. The next is blood sugar. You can also see that this is the distribution. So in that sense, you can understand all the distributions which are available there. So the same way we try to plot histogram, bioplots, and that all the things stuffs are there. Exercise induces and this all the things various peaks and all the variables in there. And now this look, this box plot is skewed. This box plot is skewed and there is outliers, so we can easily understand this. So that sense you can get some basic idea about how the data is being distributed. So the next part which comes in place, that is modeling. So the modeling part is very much important. So whatever we will do, this is a classification problem. So I have tried various methods. So basically Gaussian naive bayes and k nearest we try, and svc support vector, and random forest we have tried, and hgb classifier catch. So now we will look at the null values are 0 and we plot some heat. So in the heat map, you can see that how the variables are correlated. You can easily understand with the help of heat map. So don't worry, just because I am scrolling, you will get the code in the description. Just follow the link on the GitHub and you will got the access of the code. Next is trend test split. So we will split the x and y. So now the point is, why do we need to split the train and test? Because if we use the whole data set in the purpose of train the model, then where do we test the model? So in that sense, we need to split the data set into train and test. So now look at there. So the test size, so we need to define the code. So of what will be the changes we can made here. So this is nothing but the raw syntax, and there the 3.0.3 means 30% of our data set data is being stored for test, and 70% of the data will be used for training. And random state 42 means within the 42 there is some random selections will be happening. So we can see, simply put there, and we can see that this is the size of the trainings and this is the size of the text. So you can see that this is things, and now we need to transform the data. We need to scale the data. So we did some sort of data scaling. We use maximum and minimum scalar. So we import from the package from skit learning pre-processing, and then we transform the data. So now these are the different algorithms or models which we use. So now look at this. This is the logistic regressions which we used. You can simply use the codes or syntax there, and you can use this. So now to evaluate the result or accuracy, basically we use some sort of matrices. So we from skit learning we import some matrices, and you can see that the accuracy score we have get is 80.84%, which is quite good, which is quite good. And you can see that these are the syntax. So now why there is y test and y prediction? So because we are trying to match our prediction with the actual test data. Means we are trying to predict and try to make sure that is our predictions is matching with the real our actual data. If there is not, then our accuracy is very low or very bad, and if yes, then our accuracy is quite good. The next is Gaussian naive Bayes. There is also some simple algorithms are there. You can just see that there is the accuracy of 81.49%. So you can see that from previous the Gauss, this model performs better. This model performs better. Next comes decision tree. Decision tree, there we tried some grid search and randomized search CB. So now we will look at grid search, and we do some sort of hyperparameters. So basically you can see that these are the parameters. There is some presence of parameters or hyperparameters. So these are the parameters. By changing the parameters, we can improve the performance of our models. So this is the maximum depth which we have taken, and you can see that the sample leaf and minimum sample we all are defined very clearly, and the model we predicted, and then the accuracy comes is 90.58%. So this works really very well. So from the previous two models, this models works super fine. So now we plot the decision tree. In the decision tree, we plot the tree with some sort of plot tree. From the skit learning, we import the decision tree plotting packages, and we plot it. So in the max depth, we have defined 2. Means what? Our tree will be eliminated in the maximum depth of 2. If we put the maximum depth, if we remove the maximum depth from there, then the maximum, whatever is the whole tree will get printed over the output. So you can see that the total depth is 10. So if we put the code from here, if we remove the max depth, then total 10 the depth tree will be visible to the output. The next is random forest. So in terms of random forest, we will simply use the same syntax we will use for the random forest, and in random forest we can see that we got the accuracy of 91.23%. So in the same way, we have done some, we have plot the confusion matrix. So why do we plot confusion matrix? To look or evaluate that how many actual predictions are made and how many false predictions are being made. So you can see that these are the things and results we have got, which is quite good. And then we will look at the feature importance. So which feature is leading? So by plotting this, we can see that chest pain is the thing which is leading, so most important factor is chest pain, which is moving with the disease. So next is we use some SAP. Use SAP. So with the help of SAP, we can also plot the feature importance. So this is nothing. You can do just one way, but I just try to show you that in terms of SAP, you can also see that what are the important features. Then we look at SVM. In SVM, we will also put the syntax there, and you can see that the SVM has an accuracy of 84.09%, and in K neighbor we have done such and we can see that the accuracy is 100%, which means that my model is getting overfitted, so this model will be rejected. Now after doing a lot of stuffs and lot of models, now we need to evaluate. So in the evaluation process, we will just sort out our scores, and we can see that for our prediction model, random forest works best because k nearest overfits. So random forest has a better accuracy, and the logistic regression has the least accuracy. So you can understand. And so these are the things which you should keep in mind. The in the description, the GitHub link will be there. Just go to the GitHub link and you can see the code. Okay. So for now, that's all. Let's meet another video and discuss lot of stuff in terms of data science or business analytics.